Now, this is where I need you to add to what we did yesterday. And this is where we're looking at types of collisions. Now, you remember on that sheet, some of you were asking about this yesterday, elastic and inelastic collisions. All right, I'm going to tell you parts of this that I need you to copy down. So I'll tell you when I want you to write down something. But just look right now. All right, we're going to look at some examples of these types of collisions. All right, I'm going to use some of these bouncy balls and a little bit of clay here in just a second. All right, in this case, we've got elastic and inelastic. Now, I know you look at that and go, I bet I know what the difference is between those. It's not so obvious, though. Okay, it might not be so obvious. Different kinds of collisions. Objects stick together after the collision. Objects bounce apart after the collision. Okay, so sometimes, like right here, okay, they're going to bounce apart. But sometimes, when they hit, they're going to stick together. That's going to determine whether they're going to be elastic or inelastic. Okay, that's one of the things that's going to determine that. All right? All right, this is the first thing I need you to write down real quick. Okay, a collision in which the objects stick together after the collision is called a perfectly inelastic collision. Perfectly inelastic collision is when they stick together after the collision. Okay, just write down that first part right there. Collision in which the objects stick together after the collision. Just that first part. Stick on your face. Stick right on your face.
You got that from his cat off?
Huh?
You got that clay from his cat off?
I did.
You had clay from
All right. You don't need to write down the rest of it. Objects do not bounce at all. Okay, so a perfectly inelastic collision. And I know you might look at this and go, like, for example, a bouncy ball. You say, well, that's something that bounces. Okay? Collision in which objects stick together. Now, it's a little bit different. That's the totally opposite of a perfectly inelastic. Don't confuse elastic with inelastic. So a bouncy ball will be on the opposite end of the spectrum. Now, this would be a good example. Okay? So if I threw this and stuck it on face right there on the nose. Okay? All right, now this would be a perfectly inelastic collision. All right, let's see here. I don't think it's going to stick on that. There we go. That's a perfectly inelastic collision. All right? And you'll notice, look right here. Collision in which the objects stick together after collision. The objects do not bounce at all. I don't think this bounced. All right? If we know the total momentum before the collision, we can calculate the final momentum and velocity. So we know what was happening beforehand, and we know what happened after everything collided. All right? All right? So it's the same idea. That is perfectly inelastic. Okay, perfectly inelastic. So when they stick together, energy is not conserved in a perfectly inelastic collision. Now somebody tell me what that means. Energy is not conserved in a perfectly inelastic collision. What happens to all the energy? Okay, I gave this thing some energy, right?
The energy don't come back to you.
I gave this thing some energy, right? Okay? It's not coming back. It don't bounce. It don't do anything. Where does all the energy go?
In the wall.
It goes into the
All right, you're right. Some of it goes into the wall.
and some might come back.
No.
Well, actually, he's right. He just don't realize he's right. But he is right. Okay? He is right. Because what's something that's produced when two things collide that we hear?
Sound.
We hear sound. People don't understand sound is a type of energy. Okay? So when I throw this like that, it produces a sound. So some energy is lost as sound. Some energy goes into the wall, like he said. Alright? Somebody tell me where the rest of the energy goes. Come on, somebody tell me, where does the rest of the energy go?
Into the ball.
What?
Into the ball.
It goes into the ball to do what? Flatten it out. Good, good. That's exactly what I was looking for. It flattens it out. Guys, that takes energy. Look, let me show you something. Okay? Now look, if I just let this sit right here in my hand, it's not just going to automatically flatten out my hand. It takes energy to flatten that out. Okay, so when I throw this, all that energy goes into the wall, it produces sound, and then it takes some energy to flatten it out. Okay, so in this case, that's a perfectly inelastic collision. That energy is not used to bounce off of something. Okay? Alright. An elastic collision is one in which no energy is lost. Okay? Just write down this part right here. An elastic collision is one in which no energy is lost.
So, with elastic tape, example?
Well, that's different because there's not a collision involved. Okay, we're just looking at collisions. Man, it's collisions. Who has art?
I had last year.
I have to answer to you.
Okay? So, elastic is on the opposite end. Okay, so we've got perfectly inelastic. That's perfectly inelastic. On the opposite end of the spectrum, we've got elastic. Okay, so elastic was what I was saying a while ago. When I drop this, if this were, let's go. If I drop this, none of the energy is lost when it hits and when it comes back up. Okay, so that is elastic. But this one is not perfectly elastic. How do you know this one is not perfectly elastic? Well, you're on the ball today. That's pretty good. I'm proud of you. Actually, might be nice to you for a day. Okay? She's right. If you didn't hear, she said, it does. I know it's not perfectly elastic because it doesn't come all the way back up to where I dropped it from. Okay? So it's not a perfectly elastic collision. So when it goes down and hits, if it were, it would come all the way back up and just land in my hand. And one way I know that is because, remember I said there's a type of energy, sound energy. I can hear this thing. I can hear it hit the floor. So I know it's losing some energy in the form of sound. Okay? Partially, and guys, this is what most collisions are. Partially inelastic collision is one in which some energy is lost, but the objects do not stick together. So this is a partially inelastic collision. It goes down, some of the energy is lost as sound, and what you don't see, guys, is when this ball hits the floor, it actually compresses a little bit. Okay? Some people, if I have time, I'll show you a shot of this. Like when a golf ball gets hit, people don't see this part of it. When a golf ball gets hit, the golf ball actually shrinks down. It like contorts a little bit. Baseballs do the same thing. Tennis balls do the same thing. When they get hit, they actually contort a little bit. That takes energy to do that. So when it does that, that's losing some of the energy. But most of them are partially inelastic. The objects do not stick together. The greatest portion of the energy is lost in the perfectly inelastic collision. So in this type, that's where most of your energy is lost. Perfectly inelastic collisions. Okay? So that's kind of the main thing. And you get different types of bouncy balls. Some of them are better than others. See, that one's not bad. But still, it's not coming all the way back up to my hand. Okay? So that one's definitely not perfect. And none of these are going to be. Okay? None of them are going to be. Even though that one's even better. It comes up to about right there. So you've got about that much of a difference. And you'll notice like this one's like more like a racket ball. And it really doesn't even come close. Okay, but it's going to be the same idea that we've been talking about. Now, you're going to kind of be using these as we go along. Like we're going to do a little lab where you use these, and these to kind of look at the difference between partially elastic and inelastic. All right, now tell me this. Just kind of have to use here. If I do this right here. All right, think about it. Is this elastic or inelastic?
Elastic.
Elastic or inelastic?
Elastic.
Okay. I hear elastic. I hear mostly elastic. Okay. And if you say elastic, you're kind of right. Remember, conceivably, there's really no perfectly elastic collision. Okay, but there are some just like regular elastic collisions. This is like a partially inelastic collision because can you hear them hit? Yes, you can hear them hit, which means some energy is being lost whenever they hit, which means it's partially, partially inelastic when they do hit. All right, so that's kind of the gist of when we say they stick together. Now, if this one's here, what is that? Okay, not elastic. Okay, and that's inelastic. Okay, there's inelastic. It's not perfectly inelastic, but it is inelastic. All right, just think of this one. When you want perfectly inelastic, that's perfectly inelastic. Okay, because all that energy is hitting and boom. Tell me this. If two cars hit each other, you got a head-on collision between two cars when they hit each other. When that happens, they stick together and they don't move. Is that perfectly inelastic, elastic, or somewhere in between? All right, it's kind of somewhere in between, okay? Because they stick together, that makes it inelastic, but it's not perfectly inelastic because we hear energy. We can hear it. Since you can hear the wreck, then that's not perfect, okay? The only perfect you have is when you don't lose any energy in the whole thing, all right? All right, I'm actually going to stop right there.
Wait, what would be an example
Yes.
of
Perfectly what?
perfectly?
Perfectly elastic would be if I drop this.
Oh, yeah, wait a minute, I mean,
Inelastic. Perfectly inelastic would be this. Okay, whenever you throw something and all the energy is just absorbed there together. There's no bounce at all. I'm gonna make some of that at the end of the day.
maybe,
Actually, you know what I'm gonna sculpt with this?
you gotta pay for the play.
Huh?
I thought you gonna do that.
Really? You got to make this plate? Really? How much you have to pay?
$20, it's a project or, no, $20 for the whole year. You should make an F, make an F from her, make an F, you don't give it back. What's my name? Yeah, I think you said you just make it in and make it.
Uh-huh.